Let's write sine of theta in terms of cotangent of theta when we're in quadrant 3. So one thing that makes this tricky is cotangent is itself built out of sine and cosine together, so it's kind of hard to sort of isolate that relationship and only express cotangent in terms of only express sine in terms of just cotangent instead of some combination of cotangent and tangent. But there's a nice trick that handles lots of tricky situations like this, and it involves drawing the most important diagram. So that's going to be like this. We're in quadrant 3, so let's draw some angle theta that's in quadrant 3. Okay, it looks like maybe this is supposed to be a multiple of pi over 3, but it's not. This is just an example. I could have made this angle slightly larger or slightly greater. The only important thing about it is that it's in quadrant 3. And what we're going to do is draw our right triangle with the horizontal and vertical coordinate. And here comes the trick. So what we're going to do is label the sides of this triangle so that the cotangent of theta is actually represented in this diagram. So cotangent of theta is, let's see, it's x over y. Okay, so we need to pick side lengths for our x coordinate and our y coordinate so that the x divided by y is cotangent. There are lots of ways to do that, but maybe the easiest way is just to insist that y be 1. Actually, since we're in the third quadrant, y is going to have to be minus 1. Okay, if we choose minus 1 for y, then to make this expression that we're writing down here be cotangent, we have to have minus cotangent here, minus cotangent theta. Okay, so this expression that we've written down on the right, minus cotangent theta over minus 1, that is equal to cotangent theta. But what that's telling us is on our diagram, we need to make x be minus cotangent theta, and we need to make y be minus 1. So over here, x is minus cotangent theta, and y is going to be minus 1. And notice that we've chosen two sides for this right triangle. Now we can use the Pythagorean theorem to find the third side. The hypotenuse of this triangle is the square root of the sum of the squares of the other sides. So that's square root of cotangent squared theta plus 1 squared. 1 squared is 1. Okay, now normally we'd have to decide if we need a plus or minus here, but since we're dealing with a hypotenuse, it's the length of the hypotenuse, and so it's always positive. We don't have to worry about the negative possibility. So now we know that the hypotenuse is the square root of cotangent squared theta plus 1. And now that we know all sides of this right triangle, we can write down any trig function we want. In particular, we can write down sine theta. So sine is the y-coordinate divided by the hypotenuse. So the y-coordinate is minus 1, and the hypotenuse is the square root of cotangent squared theta plus 1. All right. And just as a quick sanity check, since we're in quadrant 3, this expression that we've written for sine should be negative, because sine is always negative in the third quadrant. So this should be negative. And let's see, the numerator is always negative because it's just minus 1. And the denominator, well, when we took this square root, we chose the positive square root. So this denominator is always positive. And so this quotient will come out to be negative, like it's supposed to for the third quadrant. So if you ever have any trouble figuring out the relationship between two trig functions, for the trig function that you're starting with, draw a version of the most important diagram where that trig function appears. And then you can use the Pythagorean theorem to find a third side, and then you can write any trig function that you want.